learning outcome is what is meant by a complete circuit. So remember we described this in the questions. A complete circuit has a battery or cell. Remember we talked about that difference, but we'll distinguish that later as well. And wires in a loop. And here's a kind of key idea with no gaps. Two is to define series and parallel circuits. So a series circuit has all the, and we use a word here, components. Component is anything that you put in a circuit. Right? A battery is a component, a lamp is a component, a switch is a component. And a series circuit is all the components one after the other. Just like a TV series, there's a particular order. You're meant to watch episode 1 before 2, before 3, etc. Now, usually you'd just be asked to identify that from a circuit diagram. So if I draw a circuit diagram of a series circuit, what we've got are the bulbs, and it could be other things, but in this case bulbs are all one after the other. And that's the space for my battery to go in. And lastly, a couple of wee dashes for my battery symbol. A parallel circuit, and I know my writing isn't the neatest in this, but that's P-A-R-A-L-L-E-L. Has separate branches. So as soon as you see there's branches in a circuit, then it must be a parallel circuit. So once again, usually what you'll find with the questions are they'll give you a picture and ask, is this a series or parallel circuit? What we've got here is each bulb in its own separate branch. This is learning outcome 3. A series circuit gets dimmer and more bulbs are added. And if one bulb breaks, anyone want to remind me what happened to the rest? Right, they don't break.
Well, not break, they just turn off.
Yeah, they turn off, good. Okay, so if one bulb breaks, the rest go off. Anybody? Okay, so this is because there's a gap in the circuit. In a parallel circuit, adding more bulbs has no effect on the others. And if one bulb breaks, the rest are unaffected. So notice I don't say just that the rest stay on. I'm saying they're unaffected, so they stay on at the same brightness. Okay, so learning outcome 4 is the circuit symbols that you need to recognise. So I've already used some of them. And it could be given either way, so you could be given the symbol and asked to write beside it what it is. Or you could just be told in words, draw the symbol for a bulb. So you need to kind of know it both ways round. If this was a kind of flashcard, you need to be able to deal with either side. Now notice in the symbol for our battery, the kind of 2 individual cell symbols I start by drawing have to point in the same direction. So the way I've picked it there, the bigger lines on the left-hand side, the smaller line on the right-hand side. And that has to be true for both of them. They could both be right to left, but they both have to point the same direction. If you're curious, the smaller side is the negative end of the battery and the bigger side is the positive end of the battery. So that was our one for a battery. Now that was the big yellow packs that we were using, remember? What you've probably called a battery all your life is a cell. Good. Okay. So a battery is a collection of cells. One of them on their own is just a cell. And the last one for now, because we will do some more as we go through the course. Switch. Okay, what are the properties that we're looking for in the neat circuit diagrams?
Battery or cell.
That's just part of, in general, that circuits need a battery or a cell. Okay, so most of them will involve that. So a neat circuit diagram, 1 is drawn with a ruler. Ideally a ruler, at the very worst, a straight edge. Two uses standard symbols, so the ones that we've just introduced. So we don't try and draw what the battery pack looks like. We just use a symbol for it. Right. 3 has rectangular lines. I.e. we don't kind of have diagonal lines going directly from one to the other. And 4, we don't put things in the corners, basically, has no components. Has no components in the corners. So like the ones that I drew for number 2. And last one for now. Can we define what we mean by a conductor?
Material which lets energy pass through it.
Yep, okay. A conductor, and then the electricity unit is that particular type of energy we're looking for it. A conductor is a material which lets electricity flow through it. E.g. copper and lead. I think that was the two examples we had the other day, wasn't it? And an insulator does not allow electricity to flow through it. E.g., I think it was rubber and glass.